Hello, I am Salvador Medina, and today I will present to you our latest work named Speech-Driven Tongue Animation. This is a collaboration between Carnegie Mellon University, Haskins Laboratories, Queen's University, and Epic Games. But first, let the result from our proposed method introduce our work.
Hello, this animation is automatically generated. We can predict both tongue and jaw movements from speech input only. It even works for different speakers. Automatic speech animation has improved rapidly in recent papers. However, even characters with great lip sync still look wrong because their tongue doesn't move. Now we can automatically animate the tongue and jaw of an avatar for any speech.
In this work, we tackle the problem of animating the tongue, lips, and jaw from a speech signal only. For this, we captured a large-scale inner mouth mocap dataset for animation purposes. Our approach to the problem is through a deep learning-based sequence-to-sequence model, which takes as input an audio stream and outputs a sequence of mouth landmark positions. The main contributions of this work are the introduction of a large-scale tongue, lips, and jaw mocap dataset, the first of its kind for animation purposes, a proper comparison of traditional versus deep learning audio representations for speech animation, and our method, which consists of a two-stage pipeline for speech-to-tongue animation. We captured the data using a Karsten's AG501 electromagnetic articulograph device by placing 10 sensors to capture the motion of tongue, lips, and jaw, where 3 sensors were placed on the lips, another 5 sensors were placed on the tongue, and 2 more on the jaw. We recorded a phonetically balanced dataset from a single English male who read 2,160 sentences, where 720 samples come from the Harvard Sentences dataset read at a regular pace and at a fast pace. Another 1,440 sentences from the Timid dataset were read only at a regular pace. This resulted in approximately 2.5 hours of speech mocap correspondence data. Our pipeline takes as input a speech signal. It is processed by an encoder-decoder model to estimate the sequence of mouth landmark locations. This sequence is used as a constraint for the rig optimizer to compute the parametric representations of each frame and finally generate the desired animation. We can divide the pipeline into 2 stages. The first part is the speech-to-tongue stage, while the second stage is the rig optimization process. During the first stage, we tested different audio feature representations for the audio encoder and different neural architectures for the articulation decoder, as well as all the possible combinations among them. For the rig optimization stage, we applied an affine transformation to the predicted mouth landmarks position into the mesh space. Then we optimized using the LBFGS algorithm to minimize the error of the corresponding landmark positions in the mesh. With respect to the predicted positions, we also added an L1 prior to overcome the sparsity of our data. The results of our method are capable of driving high-quality assets as the meta-human models from Epic Games by using only a speech signal as an input.
Can the agency overthrow alien forces? Artificial intelligence is for real.
Captain, it's the twin engines. There's only one of them now.
Dashing through the snow in a one-horse open sleigh. Over the fields we go, laughing all the way. Bells on bobtails ring, making spirits bright. What fun it is to ride and sing a slinging song tonight.
Mary had a little lamb, its fleece was white as snow, and everywhere that Mary went, the lamb was sure to go.
In conclusion, our tongue, lips, and jaw mocap dataset enables the training of data-driven models for inner mouth speech animation. A proper study shows that deep learning audio representations outperform traditional features for speech animation. We also show that simple RNN-based articulation decoders generalize across gender, age, and prosody, leveraging on the goodness of the deep learning-based audio feature representations. Our results show a limited lip animation due to the sparsity of the sensors placed on the lips. If you have any questions, please come and visit us during poster session 4.2 taking place on June 24th. Also, feel free to visit the project's website on the URL shown on screen, or access it via the QR code on top. Thank you for watching.